Hi Corey, thank you for your question. This is from worksheet number 7, Rational Exponents, and you wanted me to go over questions 12 to 15. So for this question, what they want us to do is that they want us to simplify these expressions so that our exponents are only positive, no negatives, and no fractional exponents in the denominator. And I'm going to take it a little bit further and say that there are no radicals in the denominator as well. So we might have to rationalize some denominators. The first thing I'm going to do is I'm going to deconstruct this fraction. And to do that, I'm going to separate 3 and the 4 from the variables. So what I get is 3 over 4 times m to the power of 3 over 2 divided by m to the power of 2. Now, my next step would be to simplify these two fractions. 3 over 4 cannot be simplified anymore, so I'm just going to keep that. And then what I'm going to do is I'm going to simplify this fraction here, and to do that I'm going to, because they have the same variable, top and bottom, I can just take the exponents and subtract them. So I get 3 over 2 subtract 2. Now I can't subtract straight away because they don't have like denominators. So what I have to do is find a common denominator. I'm going to use 2. So the first fraction is going to remain the same. The second fraction, I have to convert it into an equivalent fraction. So to do that, I go 1 goes into 2 twice. 2 times 2 will give me 4, and that becomes my new numerator. So just to do a self-check on that, 2 over 1 is equivalent to 4 over 2, and I would say yes, that is true. Now I'm going to go ahead and subtract the fractions. 3 subtract 4 gives me negative 1 all over 2. So that's the answer that simplifies this expression here. So again, I keep the 3/4, and I'm going to multiply by m to the negative 1/2. Now m to the negative 1/2 is the same as saying 1 over m to the power of 1/2. And that can be simplified further because we don't want exponents in our denominator. So m to the power of half is the same as the square root of m. So that will simplify this to be even further to 1 over the square root of m. Now what I can do is I can multiply the numerators together. 3 times 1 is 3, and 4 times the square root of m is 4 square root m. Now I need to rationalize the denominator, and to rationalize the denominator I am going to multiply both the top and the bottom by the square root of m. So I get 3 square root of m for the top, and I get 4 m as a simplification on the bottom. And this will be my final answer. Now, on the worksheet, they give the final answers 3m to the power of 1/2 all over 4m. It's important to see that, or to realize that these answers, both 3 square root m over 4m and 3m to the power of 1/2 over 4m, are equivalent. So two ways to write the same answer. This answer right here is removing the fraction that's the exponent, and also there isn't a radical in the denominator for either of these two answers, so that's great as well. Let's look at question number 13 and keep going with the skill set. Okay, here we are with question number 13. Same thing, we're going to simplify this to get rid of the fraction exponents. So the first thing we're going to do is separate the coefficients from the variables. So that's going to give me 2 over 4 times n to the power of 3 over 2 divided by n to the power of 1 over 3. 2 over 4 can be simplified to 1/2, and this expression here can be simplified to n to the power of 3 over 2 minus 1/3. Then what we want to do is simplify this. We're going to subtract those two fractions, but we have to have a like denominator. So 6 is going to be our like denominators. So the equivalent fraction of 3 over 2, well, 2 goes into 6 3 times, 2 goes into 6 3 times, 3 times 3 will give me 9. And then 3 goes into 6 2 times, 2 times 1 is 2. So we get 9 over 6, subtract 2 over 6 gives us 7 over 6. So that gives us the expression of 1/2 times n 7 over 6. And then we're going to simplify this. So we get 1/2 times the 6th root of n to the 7th. So then when we want to put this all together, we put that over 1, and then we multiply the numerators together, and that's just going to get us the 6th root of n to the 7th all over 2. That's going to be your final answer for number 13. Now the answer on the worksheet said that they didn't put the numerator as a radical. They kept it as n 7 over 6 all over 2, and that's fine as well. Our exponent is positive in this answer. Here it's in the form of a radical. Either or works fine as your answer. Let's look at question number 14. So for question 14, we have 4p to the power of 4/3 divided by 4p to the power of 3 over 2. So the first thing I'm going to do is I'm going to deconstruct this fraction. I'm going to separate the coefficients from the variables. So p to the power of 4/3 over p to the power of 3 over 2. I can now simplify 4 over 4 is going to be 1. So just leave it the same, and that's going to leave me with this fraction to simplify. So that fraction simplified is going to be p 4/3 minus 3 over 2. In order to subtract the fractions, I have to find a like denominator. So I'm going to use 6, and then I'm going to make equivalent fractions. 3 goes into 6 2. 2 times 4 is 8. So the equivalent fraction of 4/3 is 8 over 6. Subtract. I'm going to have another 6 as my denominator. 2 goes into 6 3 times. 3 times 3 is 9. So 8/6 minus 9/6 is equal to negative 1/6. So that's going to give me p over negative 1/6. And that's the same as saying 1 over p to the 1 over 6. And that is going to be the same as 1 over the 6th root of p. Now, as we haven't done the 6 roots in terms of rationalizing denominators, we can only rationalize denominators when we have a square root on the bottom. This doesn't match up with the answer to number 14 on the worksheet, which is p 5 over 6 over p. Now p is the same as p to 1. So if I were to simplify this, it would be the same as p 5 over 6 subtract 1 over 1. And then we need to have the same denominators in order to subtract. So that's going to give me 5 over 6 minus 1 goes into 6 times, and then 6 times 1 is 6. So that's going to give me p. 5 minus 6 gives me minus 1, 6. So that is the same as what we have here. So that's how they get to the answer on the worksheet. It does give us, this way, exponents that are not negative. But as I said, 14 is more complex than what you'll be doing on the test, but at least you can see how they came to that answer on the worksheet. Okay, let's go to number 15. Okay, the first thing we're going to do is separate the coefficients. Now the coefficients can be simplified to 2, and the variable can be simplified to 5/4 subtract 5/3. The common denominator here will be 12, so we have 4 goes into 12 3 times. 3 times 5 is 15. And then the equivalent fraction here is going to be 3 goes into 12 4 times. 4 times 5 is 20. So our answer is going to be negative 5 over 12. So that's going to give us 2 times p of negative 5/12. So here's our answer, but we're not allowed to keep the negative exponent. So in order to fix that, what I'm going to do, something a little bit different, I'm going to go 2p to the power of x, because we don't know that yet, and I'm going to put it all over p. By putting it over p, I'll be getting rid of the negative exponent, and here's how. The exponent here is 1. So if we go 2p to the x subtract p to the 1, and we know that that has to be equivalent to negative 5/12, then, or p to the negative 5/12, then that means we have x minus 1 is equal to negative 5/12. Negative 1 to give it the same denominator looks like this. X minus 12 over 12 is equal to negative 5/12. And then using algebra, I'm going to bring over the 12 over 12 over here. And that means that x is equal to negative 5 plus 12 gives me 7 over 12. And that's the exponent that goes here. So that's going to be 2p to the power of 7/12 all over p. And this is the final answer. my exponent is positive, and instead of having a negative exponent. So that's it for how they got those answers on the worksheet. I hope it clarifies those questions a little bit more, but these would be really stretching the skill set that we're using or learning in the rational exponents section. So you won't see these types of complex questions on the test, but hopefully your understanding of how they've come to the answers is a little bit better. Thanks again for your questions, and thanks for watching. Bye for now.